Welcome to our amazing section with a little tutor. We are learning is made simple. And in today's video, we are going to be looking at an amazing concept, which is the concept of indices. So we are going to look at what are indices and what are these laws of indices. So please, I want you to follow closely. Now, when we say indices, what do we mean? When we say indices, it simply talks about power. Indices, that is same thing as power. So what does this mean? It simply tells us the number of times a number is multiplied by itself. It simply tells us the number of times a number is multiplied by itself. Now let's give an example. If I have 2 times 2 times 2 times 2. In index form, this is 2 raised to power. How many times is 2 multiplied by itself? We have 2 multiplies itself. How many times? We have 1, 2, 3, 4. So this is 2 raised to power 4. So it tells us the number of times a number is multiplied by itself. That's the law of indices. Now, why do we need this law of indices? Now we know the definition of indices. Why do we need this law of indices? We need this law of indices because it tells us how to simplify expressions with powers accurately. This law of indices, it helps us know how to simplify expressions with powers accurately. And in today's video, we are going to be looking at about 4 laws of indices and questions involving these expressions and how we apply this law. So I want you to follow closely. Now, the first law of indices we are going to look at for this video, the first law of indices, we have the product law. We have the product law. Now, what is this product law all about? The product law states that when we have same base, what do we do to their powers? We add their powers. When the bases are same, we add their powers. And also, before I forget, the product law is also known as the law of multiplication. So when we have same base and they are multiplying, we add their powers. Now, what do we mean? When we have a raised to power m, when we have a raised to power m times a raised to power n, because the base are same, we go ahead to add their power. So our final answer will be a raised to power m plus n. Now, so we ask m plus n. The answer is not mn. No. M plus m can be added. Why? Because they are not like terms. But when we have m times n is mn. We can't add the powers because they are not like terms. Now let's look at an example. Let's look at example 1. We have 2 raised to power 3 times 2 raised to power 4. Now in this expression, we can apply the product law or the law of multiplication here. Why? Now there are 2 things that you have to take into consideration. The first one is because the base are same. The base here is 2, the base here is 4. Not just because the base are same, but because they are also multiplying. So we can go ahead to add their powers. So we are going to have that this is 2 raised to power 3 plus 4. And our final answer we are going to arrive at 2 raised to power 7. Now, most times students get it wrong. In scenarios like this, there are times when you are given 2 raised to power 3 plus 2 raised to power 4. And they just assume because I have same base, I go ahead to add their powers. Now, this is wrong. Why? Because of this is a plus sign. Alright? So let's look at the next law. We are going to be looking at the next law. Now, the next law we are looking at is the quotient law. The quotient law. The quotient law, which is also known as the law of division, it states that when they have same base, we go ahead to subtract their power. When we have same base and they are dividing, that's why it's called the law of division. We can go ahead to subtract their powers. Now, what do we mean? The quotient law which is also known as the law of division, is expressed as A raised to power m divided by A raised to power n. So because they have same base, criteria 1, and they are dividing, we go ahead to subtract their powers. So we're going to have our answer to be A raised to power m minus n. Now, a very good example to buttress our point, we have example 5. Example 5, we have 5 raised to power 6 divided by 5 raised to power 2. This can be rewritten as 5 raised to power 6 divided by 5 raised to power 2. Because now we can go ahead to apply the quotient law, which is known as the law of division. Why? Because their base are same, criteria 1, and then they are dividing. There's a division sign. Then we can go ahead to subtract their powers. So our final answer will be 5 raised to power 6 minus 2. And then we are going to have 5 raised to power 4. There are times when students get to miss this quotient law. There are times they are giving question like 5 raised to power 6 divided by 4 raised to power 2. Now we can't apply the quotient law here because their base are not same. The base here is 5, while the base here is 4. So for you to apply the quotient law, or for you to apply the product law, which is known as the law of multiplication, the base has to be same, and then the sign has to be same. If it's product law, it has to be multiplication, and if it's quotient law, it has to be division. And remove the third law. The third law we are going to be looking at the power of power. We are going to look at the power of power. Now, what do we mean by the power of power? What does this law imply? Let's explain. What does this law imply? The law simply implies that when we have a number that is raised, when we have a power that is raised to another power, please pay attention. The law says that when we have a power that is raised to another power, what do? We multiply both powers. Now the power of power is expressed as we have a raised to power n, or bracket raised to power n. So you can see the power of n here is n, and it is raised to another power. The power of power law states that we multiply both powers. Now, what does this imply? It's simply that this will be a raised to power n times n, which will give us our final answer to be a raised to power n. When a power is raised to another power, the both powers are multiplied together. Now, let's look at an actual example to back up that law. Let's look at example 3. Example 3, we have 3 raised to power 2, or bracket raised to power 4. We see that this 3 already has a power 2, which is still raised to another power. So what are we going to do? We have to multiply both powers. So this will be written as 3 raised to power 2 times 4. We multiply both powers. And then our final answer will give us a number of 3 raised to power 8. And that's the application of the power law. And then the last rule of indices for this video, we are going to be looking at rule number 4. which is the power of product. Please, I want you to pay attention closely. So you don't mistake the power of power law and the power of product law. What do we mean by this power of product? First of all, what do we mean by the word product? When we say product, we are simply saying when two numbers are multiplied together. When two numbers are multiplied together, that's when we talk about product. Now let's look at the law together. When we say power of product, we are simply saying that when two numbers are multiplied together and it is raised to a certain power. What does that imply? We are simply saying that what each of those numbers are raised to that power. I come again. When two numbers are multiplied and it is raised to a certain number, we are simply saying that each of those numbers, keyword each of those numbers, they are also what raised to that power. Now, this power of product law is expressed as if you have A, for example, we have AX raised to power 2. These are two variables, A and X. The coming together of A and X is what we have called product. Because when I say product, I'm talking about what? Multiplication. Because A times X is what? AX. So when two numbers are what? Or variables are multiplied together and they are raised to a certain power. What does that mean? We are simply saying that what? Each of these factor, each of these number is raised to this power. So this is equal to what? A raised to power 2 times X raised to power 2. That's what we mean by what? The power of product law. Now let's look at an example to back up this law. Now we have example 4. Example 4 says 2x raised to power 3. Using the power of product law. Now, first of all, let me say something, because at Elite Tutors, we look out for the understanding of our learners. First of all, when we see an expression like this, why should we use the power of product law? Because, why are we going to use the power of product law? Because we have two numbers. We have two items. We have 2 and we have x. And it is what both of them are raised to the power of 3. But in a situation where we have what? In a situation we have, for example, our power of power. So don't mistake the both of them. In a situation we have 3 raised to power 2 and still raised to another power. We can't use the power of product law, but rather the power of power. So using the power of product law, when we have what? 2 numbers. So this implies that this is equal to 2 raised to power 3 times x raised to power 3. Each of these numbers they are being raised to the power. Now, when we have 2 raised to power 3, we are simply saying 2 will multiply itself 3 times. Alright? So 2 raised to power 3, we have that this is what? 2 times 2 times 2. 2 times 2 gives us 4. 4 times 2 gives us 8. Alright? So this is equal to what? 8 times x raised to power 3, which our final answer will be 8x raised to power 3. And before I also continue, I would like to say this before we come to the end of this video. When we have x raised to power 3, x raised to power 3 simply means x into what? X multiplying itself 3 times, which is x times x times x. X times x is x raised to power 2 times x raised to power 3. Most students mistake it to be what? There's a difference between x times x and x plus x. X times x is 2x, but x times x is x raised to power of 2. Now we also have about 2 questions, and this we are going to be solving number 5. Please, I want you to follow. We are going to be solving number 5, and I want you to solve question 6. And this is a little secret. For question 6, you are going to be applying the power of product. You are going to apply the power of product. I want you to solve question 6, and I want you to give me the answer in the comment section. But But for question 5, we are going to be making use for question 5. We are going to be making use of for question 5. We are going to be making use of the word. So we are going to be making use of for question 5. We are going to be making use of the power of product law. Now, why are we making use of? Because we have two numbers here, and they are being raised toward this power. It simply means that this will be 2 raised to power 2 times 3 raised to power 2. So let's quickly solve that. Let's solve it here. So when we have 2 raised to power 2 times 3 raised to power 2. What does this imply? It simply implies that because we have two numbers here, this is 2 raised to power 2 times 3 raised to power 2. Now we have that 2 raised to power 2 gives us 4 times 3 raised to power 2. Right? That is 3 multiplying itself twice, which will give us 9. So we have that 4 times 9 gives us 36. And these are final answers. So you can see that for question 5, we are having a whole number. Why? Because we don't have any variable. When we say variable, we don't have any data. We've come to the end of this video. Please don't forget to like, share, and subscribe this video. And watch out for part 2. In the part 2, in the next video, we are going to be looking at different laws like the zero index law, the fractional indices law, the negative law. So watch out for part 2. Thank you very much.